Ever wonder what a traffic light is thinking? The common myth is that it's just a simple timer, mindlessly cycling through red, yellow, and green. But that's not true. Traffic lights aren't just timers. They are decision systems. Every day, they solve one of the most complex coordination problems we face. How to move thousands of vehicles and people safely through a single point where their paths must cross. An intersection is a battleground of competing flows. You've got cars going straight, cars turning left, cars turning right, pedestrians, and cyclists, all wanting to occupy the same space at the same time. The traffic signal's job is to act as a referee, giving each flow its turn while minimizing delays and preventing collisions. It's a delicate dance of timing, and how that dance is choreographed can make the difference between a smooth commute and a frustrating gridlock. So how do they make these decisions? Well, there are two main types of traffic signals. The simplest is the fixed time signal. These run on a pre-programmed schedule, cycling through the same green and red phases over and over. You often find these at intersections with very predictable traffic patterns. For example, the morning rush might get a longer green light than the midday lull. Engineers study traffic data for days or weeks to determine the optimal schedule for that specific intersection. But what about intersections where traffic is unpredictable? That's where adaptive signals come in. These are the smart ones. Instead of a fixed schedule, they react to traffic in real time. They use sensors to see what's actually happening on the road. You've probably driven over one of these sensors without even realizing it. They're often induction loop coils of wire buried in the asphalt. When your big metal car passes over them, it changes the magnetic field, and the controller knows a vehicle is waiting. Other systems use video cameras with image processing software to count cars, or even radar and infrared sensors. These systems measure traffic volume and cues, then adjust the green light duration to clear the busiest lanes first. Now, let's zoom out from a single intersection to an entire city. A smart signal is great, but its real power is unlocked when it talks to other signals. This is called coordination, and it's what creates a green wave. A green wave is when a series of traffic lights along a major road are synchronized, so that if you travel at a specific speed, you'll hit one green light after another. The signals pass information between each other. The first light tells the second one, "Hey, a platoon of 20 cars just left here. They'll be at your location in 30 seconds. The second light then prepares to turn green just as that group of cars arrives. This keeps traffic flowing smoothly along major corridors and reduces the constant stop and go that wastes fuel and time. These citywide networks are managed by a central traffic management center, where engineers monitor the flow and can make adjustments for accidents, special events, or unusual congestion. So if we have all this amazing technology, adaptive signals, sensor networks, green waves, why do we still get stuck in traffic? The simple answer is that traffic management is a game of trade-offs. The goal isn't just to move cars as fast as possible. It's about balancing efficiency with other critical needs. Safety is number one. The system needs to provide enough time for cars to clear the intersection and prevent crashes. Then there are pedestrians. They need their own walk signals and enough time to cross safely, which takes time away from vehicles. We also have to account for public transit and give buses priority, and most importantly, clear a path for emergency vehicles. When an ambulance or fire truck approaches, its transmitter tells the traffic signals to turn all lights red except for the one in its path, which turns green. This life-saving feature intentionally disrupts the normal flow of traffic. So a traffic signal isn't just solving for speed. It's solving for safety, fairness, and emergencies all at once. This brings us to a final crucial insight. Traffic signals don't actually eliminate congestion. They distribute it. Think about it. At any busy intersection, there is always more demand for green time than is available. The system can't give everyone a green light at once. So its real job is to manage the queue, deciding who waits and for how long. It's a constant balancing act, shifting the delay from one direction to another to keep the entire network from grinding to a halt. The perfect traffic system isn't one with no waiting. but one where the waiting is managed so intelligently that the whole system serves the most people as efficiently and safely as possible. Next time you're stopped at a red light, remember you're not just waiting. You're part of a massive, dynamic, citywide puzzle being solved in real time. The world runs on systems we rarely notice. If this one made your everyday life a little clearer, consider sharing it. And subscribe to explore more of the silent systems around us.